So here we're asked to find g f x. That means g of f. So g of f. That would be f squared plus 6f, oh dear, plus 6f plus 1. Just as gx is x squared plus 6x plus 1, so gf is f squared plus 6f plus 1. But remember that fx is 5x minus 3, and so we're going to have 5x minus 3 squared plus 6 times 5x minus 3 plus 1. And it says to give the answer in the simplest form, so we have to multiply out our brackets and collect like terms. 5x minus 3 squared is 25x squared minus 30x plus 9 if we go through all the steps. Add 6 times 5x is 30x. Add 6 times minus 3 is minus 18 plus 1. This thing is now going to be 25x squared. There's a minus 30x and a plus 30x which cancel out. And 9 minus 18 plus 1 turns out to be minus 8. So now I'm asked to make x the subject of 3m plus xy equals xp over 4. I think I'm going to need some room for this, so let's delete the previous work and get stuck in. Once again, this one's going to be a little bit complicated because we've got x appearing in more than one location. But remembering the same procedures that I would use for simplifying for solving equations are also used here. The first thing I want to do is eliminate my fraction. So I'm going to take every term and I'm going to times it by 4, because that will get rid of that divide by 4. I would then end up with 12m plus 4xy equals xp. If x is going to be the subject, I want everything with an x in it on the left-hand side and anything without an x on the right-hand side. So I'm going to hang on to my 4xy. I'm going to move my xp over to the other side, over the equals, so it becomes minus xp. And my 12m I'm going to move over the equals to become minus 12m. Now if this was an equation, I would be looking at something like 10x minus 2x, and I could collect those terms together to say 8x. But because these terms involve y's and p's, I can't do that. I'll do the next best thing, which is to factorize out the x, which leaves 4y minus p, and that's going to be equal to minus 12m. Now if I divide by whatever this number is, 4y minus p, it'll cancel out on this side, and to maintain the balance I've got to divide by it on that side. So here's my solution. X equals minus 12m over 4y minus p. So here's another functions question. I've got 3 different functions to work with, and the first thing it asks me to do is nice and simple, work out f of 5. F of 5 is simply f of x with a 5 in it. So 3 minus 2 times 5, and that's equal to minus 7. In the next part of the question, I'm asked to find gh of 3. I'm going to split this work up into first of all finding gh of x and then putting 3 into it. So g of h is where I get started. G of h is equal to 4 over h. But hx is 4 to the power of x. So this thing becomes 4 over 4 to the power of x. This is gh of x. To find gh of 3, I have to substitute 3 for the x. So 4 over 4 cubed. This is going to come out as 1 over 16. You could write that as a decimal if you want, but the fraction is just fine. To find f inverse of x, I need to swap the x and the f of x, relabel the f of x to make an inverse, and rearrange to make that inverse the subject. So looking up at the f of x, I first of all do my swap, writing x equals 3 minus 2 f of x. I've swapped the f of x and the x around. I'm going to relabel my f as an inverse, because I did that swap. Now I rearrange to make that inverse f of x the subject. I'm going to start off by moving it to the other side and moving the x this way. That's going to get me 2f of x equals 3 minus x. Now if I simply divide by 2 on both sides, I've achieved my goal. Now it's asking me to show that hfx is 64 over 16 to the power of x. Now this looks like it's going to be fairly complicated, and certainly might be worrying you as to where that 16 to the power of x is coming from, but I'm going to start off by doing what I always do, which is getting hf of x. So hf of x is h of f, which is 4 to the power of f, which is 4 to the power of 3 minus 2x. This is hf of x. Now I need to show that this thing is 64 over 16 to the power of x. This is going to be a laws of indices problem now. Remember that if I were to divide two numbers, I would subtract their powers. So a subtraction up here in the indices indicates a division. 4 to the power of 3 over 4 to the power of 2x. Look at it this way around. If I were to divide these two terms, I would subtract their powers, and that would certainly leave me here. I'm just doing it backwards. Now 4 cubed is 64. This is good news. On the bottom line though, I've got 4 to the power of 2x. Remember, if we multiply two powers, that's the same as doing a power of a power. So I could write this as 4 squared to the power of x. A power of a power multiplies, so this would certainly equal 4 to the 2x. And 4 squared is 16. So that's where we're getting our solution from. Now we're getting a decent amount of credit just for forming hf of x in this form over here. Doing the manipulations into the index form is going to get us a couple more marks, but don't be put off if you don't see where the final answer is coming from. You should know where to start, and if you don't get all the way there, you've still picked up marks on the way. Now we're asked to find, we're not done with this question yet. Now we're asked to find the value of x when hx equals g of 0.5. So, hx is 4 to the power of x, and g of 0.5 is gx with a 0.5 in it. That's 4 divided by 0.5. In other words, what I'm solving here is 4 to the power of x equals 4 divided by 0.5, which is 8. Now, if 4 to the power of x equals 8 and I want to know what x is, we're going to struggle to solve this thing because we don't have a way of isolating x. I would really like to write both sides as 4 to the power of something so I can compare the powers. But 4 to the power of something never gets to 8. We have to be even sneakier than that and write each side as 2 to the power of something. So, 4 is 2 squared. 2 squared to the power of x. And 8 is 2 cubed. 2 squared to the power of x is 2 to the power of 2x. And that's equal to 2 cubed. Now, 2 to the power of this equals 2 to the power of that. So this must equal that. 2x must equal 3, which means x equals 1.5. So if we're trying to solve an equation, and there's an x in the power, then we have to look at our laws of indices. and get something on both sides with a power so we can compare the powers, but that something needs to be the same something. We've seen an example where I had to turn one side into, I think it was a 3, if I remember correctly. But here we have to turn both sides into 2's, because there's no way to express 8 as a power of 4. This is especially sneaky. Another 3 functions, f of x equals 1 minus 2x, g of x equals x plus 4, and hx equals x squared plus 1. I'm asked first of all to find f of minus 1, which simply means replacing the x with a minus 1, remembering to use brackets for my negative number, and I'm doing 1 minus 2 times minus 1, which is the same thing as 1 plus 2, which is 3. Solving the equation 2f of x equals g of x is simply a case of following instructions now. 2f of x, well, that is equal to 2 times 1 minus 2x. And g of x is x plus 4. Multiplying out my brackets and collecting my x's together on one side, my numbers together on the other, gives me x equals minus 2/5. Or if you prefer, minus 0.4. For part C, I'm asked to find f(g(x). Once again, this is f of g, which is 1 minus 2g. Remember though that gx is x plus 4, so this is 1 minus 2 times x plus 4. In its simplest form, we will expand the brackets, being careful of the minus sign. 1 minus 2x minus 8. And 1 minus 8 is minus 7, so this comes out as minus 7 minus 2x. And there's our answer. Now here we've got a question asking us to find h(h)(2). Let's start off by finding h(h)(x), which is h of h. This is h squared plus 1. If h of x is x squared plus 1, then h of h is h squared plus 1. But we have to remember now that h squared is x squared plus 1 squared. So h squared plus 1 is x squared plus 1 squared plus 1. Let's multiply this bracket out carefully. X squared plus 1 times x squared plus 1 is equal to x to the power of 4 plus x squared plus another x squared plus 2x squared plus 1 times 1 is 1. So h of x is equal to x to the power of 4 plus 2x squared plus 1 is plus 2. And so h(h)(2) is 2 to the power of 4 plus 2 times 2 squared plus 2, which is 26. And I'll do the final part of this just right down here at the bottom. h(g)(f)(x) has to equal this thing, and we're asked to find the values of p and q. Well, let's break this down into stages. Let's do g of f. G of f, if we go back up to the top, is f plus 4. And that is equal to 1 minus 2x plus 4 and that is equal to 5 minus 2x. So h of gf is equal to GF squared plus 1. Which is equal to 5 minus 2x squared plus 1. I'm going to multiply out my brackets, which gets me 25 minus 20x plus 4x squared plus 1. Remember, this is two brackets multiplied together. This thing is now equal to 4x squared minus 20x plus 1 plus 25 is plus 26. So now it reckons that HGF is equal to 4x squared, which I agree with, plus px. Now I've said minus 20x, which means p must equal minus 20, plus q, and I've said plus 26. So q must equal 26. So here we have three functions composed together. The principle works as it does for the others, but we just have more steps involved. This question is tricky and you should pay close attention to how it's done.